Hello, hello. This is Mika, also known as Banana Man, and this is the new calculus channel. Now, today I want to show you how you can do arithmetic with ratios purely geometrically. So, I'll be showing you all four operations: subtraction, addition, division, and multiplication. Now, you've never been taught this during your education, your mainstream education. And that's because none of your teachers or professors even knew about this. This was actually discovered by my favorite teacher, the great John Gabriel, who has allowed me to make a nice video on his channel. Now, first we got to look at the setup here. So we have two triangles. The first triangle represents this blue-green ratio. So we have a blue antecedent here and a green consequent. And our second triangle represents this red-orange triangle. It's a red-orange ratio. The red line segment is the antecedent and the orange line segment is the consequent. Now you can see that the antecedents are in line with each other and the consequences are in line with each other. And all of these line segments meet at this vertice. Now, the angle at this vertice is 90 degrees, but it's actually arbitrary. It could be any angle you want. I just picked 90 degrees because it looks nice. Now, this first ratio is the ratio that the operation is being done to. And the second ratio is the ratio that the operation is being done by. So, for subtraction, we are taking this first ratio and we're minusing the second ratio. Now, let's look at the second step here for subtraction. This step is very important since it actually allows us to do the arithmetic. And it comes into play in all the operations. So, in this step, we scale up the second ratio so that it has the same consequent as the first ratio. And the reason we're doing this is because the consequent of a ratio sets the scale for its antecedent. So if we want to work with these antecedents on the same scale, we have to make the consequences equal. But we also have to preserve the proportion in the second ratio. And the way we do that is by using similar triangles. So every side in this small triangle has a corresponding parallel side in the second triangle, and that preserves the proportion here. Now, after we do that scaling up, we can then take the difference between the two antecedents in the obvious way. We're just going to take the part of this blue line segment that isn't overlapped by this red line segment. And that's how we get the antecedent for our final ratio. And we're just going to use the common consequent of the two ratios after we scaled them. And that's how you get the difference between two ratios. Now, addition. Addition has the first two steps of subtraction. So it has the setup and it has the scaling. But instead of taking the difference, we're going to take the sum of these two antecedents. And then that's how we get the sum of these two ratios. Okay, division. Division is different from subtraction and addition. Now the first two steps are the same, but as you can see here, we've discarded this common consequent. And the reason why is because the division of two ratios is actually a ratio of these two ratios. So what we do is we take the ratio of these two ratios, and then since they have the same consequent, it becomes useless information. So all that's needed is the antecedents of the two ratios. So we take this blue antecedent, and that becomes the antecedent for this ratio. And we take the red antecedent, and it becomes the consequent for this final ratio. And that's how we divide two ratios. Now lastly, we got multiplication. Now, this might be a bit strange to learn, but multiplication is actually the most complicated out of all the operations. And the reason is because multiplication is actually defined in terms of division. So you can see here at the second step, we're not scaling things up. First, what we're doing is we're flipping the second ratio, and that's because multiplication is division by a reciprocal ratio. So that's why we flip it. And then after that, all the steps are the same as in division. So we're going to scale things up, and then we're going to make a ratio out of the consequences and discard this common consequence. And that's how we get multiplication of two ratios. Now, there's actually a very important relationship between these operations and the operations in algebra, the operations we have with numbers. And that relation is that if you were to measure both of these ratios and you got two numbers, let's say A and B, and then you were to measure this last ratio, and let's call it C, then A times B would equal C. So there is a direct relation between the operations in algebra and the operations with ratios. Now, you can actually play around with this. You can play around with this in the applet in the description below. You can make different ratios and everything. You can also become a member, like, subscribe, and study the new calculus. I'm Banana Man. Bye-bye.